Okay, today's lesson, guys, we're going to talk about how to show work for physics problems. Okay, anytime that we have an expectation or anytime we have work to show in a physics problem for ICP, then we're going to follow these same expectations. And the reason why, I'm providing you guys the equation list. I'm not expecting you guys to memorize the equation list. I'm merely just asking that you understand what variables mean what units are associated with those variables, and how to plug in and rearrange the equations. Okay. Now, one of the questions I've always received from students is, how do I know what variable a number is in a problem? Okay, so, and the answer is it's based on the unit that question has, or that number has in the question. So, over here in this table, I have like the variable in the equation d. For example, in this very first top left equation right here, we have the variable d is for distance, okay? And the number that will be plugged in for distance and its standard unit is the meter. But understand, you might see things like kilometers or centimeters, or maybe even some of our English units like feet and miles. Okay. Just like with time, even though the standard unit is seconds, we might also see minutes, hours, days, weeks, years, anything that means a time. Now, velocity, the standard unit is meters per second, but you could see things like kilometers per hour or meters per minute if the object's moving really slowly. Now, the acceleration unit, and the first four variables are the ones we've talked about and introduced. Acceleration is in meters per second squared. And so what acceleration is meaning, it's kind of a weird unit, but the standard unit means that every second the object's going to increase its rate of speed by that many meters per second. So this table that's on this page here is going to be extremely important that you guys understand the standard units. And this PowerPoint slide will be posted in the module for chapter 11 and 12. And so if you ever have a question, you need to revisit this. This will be a helpful PowerPoint to revisit. I'll also post it in the helpful materials unit as well, or module as well. So steps to showing work. All right, when you are reading through a problem, we want to first take numbers that are in the problem and start assigning them to a variable based on the unit. We're going to just do that off to the left. We're going to state which one of those many equations we're going to use. We're going to substitute into the equation and then provide the answer with the unit. Sometimes I like to refer to it as the guess method, right? Given variables and numbers in the equation, the unknown, the equation, the substitution, and the solving of the equation. Okay, what's the answer in the units? Now, I do show students that really struggle algebraically. This is a little trick to help you rearrange. And we can use this triangle to rearrange equations that are given as long as they're multiplying or dividing by one another. And so if I take, for example, my speed equation, right, v equals d divided by t, I can set this up so that we can have in the base equation, the given one, d is over t. So in the triangle, there's three quadrants to it. The top quadrant, d, because d is over t, and then our other variable, v, will go on the bottom. Now, if I wanted to solve for, say, time, something that I've not already rearranged to solve for, I just cover up time with my finger or thumb. Here I highlighted it, and we're left with d over t. So that tells me that time equals distance divided by speed. Or another example, we could have to solve for distance. And so if I have to solve for the distance, I can take distance equals, and because V and T are in the same level of the triangle, they're being multiplied by one another, V times T. So this equation can be used for almost every equation on this equation sheet that you guys will receive this year. But one equation that we can't use it with is the VF minus VI. This triangle only works to rearrange equations that are set up as multiplication and division. And so we're going to have to do a further step if we need to solve for a velocity, which we'll cover a little bit later in the notes. So let's start doing a couple of examples. And again, every time that we're doing problems, you are going to follow the same steps. And I understand you might be like, oh, I can just use it in a calculator, but I need to be able to see your work. So when you read problems, if you want to go number hunting, and what I mean by number hunting is without actually reading the problem, I can look in the problem and I can find the numbers in the problem. And here I have 400 meters and 10 seconds. Now, meters, out of the variables that I've covered, is the variable for distance. And so I'm going to assign that to D, 400 meters, and 10 seconds is our time. And at this point, after I go at number hunting, I do kind of have to read to find out what the question's asking about. And so it says right here, what's the average speed? Okay, the question as a whole reads, what's the average speed of a car that travels 400 meters in 10 seconds? So I'm looking for V. This right here is the list your variables. And now I need the equation. Out of all those equations, we're using the equation V equals D divided by T. Okay, and so here now we're ready to plug in. V will equal 400 meters all over 10 seconds. And now after this, we're ready to do the math. This says 400 divided by 10 in the calculator, which will give me 40. And then unit-wise, if I'm looking at these units, nothing cancels here. And so I need to have meters per seconds. Okay, and if you wanted to write it like I wrote it, you can. Some people like to write it as 40 meters per second, like that. Either way is acceptable. I wouldn't mark you wrong, but we need to be able to come up with our answer in units, and we want to make sure we clearly see our answer. So let's look at another problem here. Again, I'm just kind of number hunting. I'm not really looking for what the problem's saying right now, but I see 10 kilometers per second. Now, of the variables we've learned so far, kilometers per second is not one of the units that we would have for a standard unit, but kilometers per second is a speed unit. It is talking about something that is traveling a distance per unit of time. So this is 10 kilometers per second. And it says 30 kilometers is the second number I come across, and that's a distance. At this point, I'm going to find out what is the question asking me about. So here I see, how long will it take? How long is a time? Okay. So here, again, we're using the speed and velocity equation of V equals D divided by T, but I'm solving for T. So this might be a time where you want to use that triangle to rearrange the equation, right? We would have D over T and V on bottom. We would cover up T, and the equation would be T equals D divided by V. Now, before you plug in, we do want to double check one thing because I have a distance unit in speed because it's kilometers per second. I need to make sure that it matches my distance unit. So here I have kilometers and here I have kilometers. And that's good because now we don't have to make any unit conversions. It's going to cancel and leave us with a time unit. And so we're going to plug in T equals my distance, 30 kilometers, all over my time, my speed, 10 kilometers per second. And here we see in the problem with this setup, kilometers in a numerator and a denominator. And now we have a time. 30 divided by 10 provides me 3. And then my unit, the only unit left is seconds. Okay, and when we have per seconds in the denominator like that, it's actually going to become a numerator, which is why we just put seconds on the time. The next problem I have, again, go number hunting. It's a good strategy. 85 meters per second and 30 seconds. So let's start with the meters per second. That's a speed, 85.0 meters per second. And seconds is just a time, t. So 30.0 seconds. And now I got to read and find out what's it asking about. If a race car is traveling at 85 meters per second, how far is a distance, right? So we're looking for d. And here we can use the triangle to help us rearrange again because the equation v equals d divided by t isn't solved for d. We have v and t on the bottom. So if cover up d, v and t are in the same plane, which means multiply. So d will equal a v speed times a time. So I have my equation. I want to substitute into this equation 85.0 meters per second times 30.0 seconds. And I knew I was ready to plug into the equation because my time unit of seconds matched the unit of time in the speed unit meters per second. So if I was given a time in minutes, I would have had to convert to seconds. Okay, so distance will be 85 times 30, and that gives me 2,550 meters. So we've just worked a speed problem out. We worked one for the speed, we worked one for distance, we worked one for time. So you should be able to solve for any of the types of problems involving speed. So now let's take a look at another type of problem, an acceleration problem. Here I have number hunting. I'm not even really reading, just number hunting. Meters per second, that's a speed. My next number and unit is 40 meters per second. That's also a speed. Now, the last one is 2 seconds, and that's a time. Now, I have 2 speeds, which if I were to go back up here, that's going to be my equation for acceleration, Vf minus Vi. Now, this subscript F here indicates the final speed, and the I is my initial speed. Okay, so We need to distinguish which one of the speeds is initial and final. And so I'm looking here from 20 means that 20 is the initial to 40. And so that's my final speed. Uh-oh. And so, again, F is for initial, I is for initial, F is for final. And so my acceleration is equal to VF minus VI, all divided by T. So I need to find the difference first. When I plug in, I would have 40 meters per second minus 20 meters per second. All of that being divided by the 2 seconds. So my acceleration is 20 meters per second divided by 2 seconds, which is equal to 10 meters per second, which the per second and per second is really like 10 meters per second times 1 over seconds. And so my seconds combine for 10 meters per second squared. And that's the SI unit of acceleration. My last problem. If a ball is dropped from a height of 50 meters, okay, so 50 meters here. Meters is a distance. That's the only thing we've really learned. The question did use height of 50 meters. Now, all that means is that if we had the ground here, then that ball is 50 meters in the air when it starts. Okay, so our distance is a vertical distance. So how fast will the ball be traveling? And it says 3.4 seconds later. 3.4 seconds is the time. Now, initially, this does look like a V equals D divided by T equation, because it does ask for how fast. However, we know that as the ball falls, the acceleration of gravity on Earth is 9.8 meters per second squared. So we're taking the frame of reference that this ball is being accelerated towards Earth due to gravity, and it wants to know how fast is it traveling at that time, 3.4 seconds. So that's our final speed. Now, initially, a ball that's being dropped has no speed. It hasn't been dropped yet. It's not moving. So VI in this equation is 0 meters per second. Now, again, I'm searching for VF. Unfortunately, because my equation is A equals VF minus VI divided by T, I can't use the triangle necessarily to rearrange. But I can break it down into the change in V divided by A times T. And so I can say VF minus VI is equal to A times T. And I can then substitute into my equation, where 9.8 meters per second squared times T, 3.4 seconds. And if we're subtracting 0, I can just get rid of that. VF is my my answer here. So 9.8 times 3.4 gives me an answer of 33.32. And now my unit, seconds here, is going to get rid of the square portion there. And so I'm left with just this speed, meters per second. So again, remember, when you're doing work for my class, you need to show the work by listing your variables, stating the equation, substituting into your equation, and solving for the answer. If you have any questions, please ask me in class or with an email if it is not during class hours. Thanks.